Graphing linear inequalities. A linear inequality has an inequality symbol, such as less than, greater than, less than or equal to, or greater than or equal to. The solution for a linear inequality is indicated by shading the region of the coordinate system where the ordered pairs satisfy the linear inequality. Graphing the inequality involves graphing the line, determining if the line should be solid or shaded, graphing linear inequalities. A linear inequality has an inequality symbol such as less than, greater than, less than or equal to, or greater than or equal to. The solution for a linear inequality is indicated by shading the region of the coordinate system where the ordered pairs satisfy or make true the linear inequality. Graphing the inequality involves graphing the line, determining if the line should be solid or dashed, testing one of the two sides of the line with a test point to determine which side of the line to shade, and shading the side of the line where all the solutions are. Now, generally, this last statement is true. We shade the side of the line where all the solutions are. For my students that are in linear algebra and probability, when we graph feasible regions, we actually shade the side of the line where the solutions are not, or where our test point is false. The reason for this is that when we are graphing multiple equations on a graph and shading where all the regions are not, or all the regions are false, then the white section of the graph is our feasible region, and it makes it easier to see. If we shade where all the places are true, then we end up with lots of overlying colors and have a very difficult time figuring out where the feasible region is. In today's lesson, though, I'm going to be using the traditional method of shading the side of the line where all the solutions are. The line you draw for the inequality is called a boundary line. This line will either be solid or dashed. A solid line indicates that the ordered pairs on the line satisfy the inequality, make a true statement. A solid line is used with less than or equal to, greater than or equal to. While a dashed line indicates that the ordered pairs on the line do not satisfy the inequality, a dashed line is used for less than or greater than. A short version of this is essentially, if there is an equals piece under the less than or the greater than, use a solid line. If there's not a equals piece under them, use a dashed line. Let's take a look at an example. This example says, graph the inequality 3x minus 5y is less than 15. So this particular inequality is in standard form. Because it's in standard form, it's rather quick to find the x-intercept and then the y-intercept. To find the x-intercept, I can take 3x, set it equal to 15, and find out that x equals 5. So my x-intercept is 5. Similarly, I can take the negative 5y and set it equal to 15, solve for y, and get negative 3 for a y-intercept. I come over to my graph, I plot the x-intercept of 5, I plot the y-intercept of negative 3. Now then I have to decide if this should be dashed or solid. This should actually be a dashed line. So I go in here and I would want to make sure I have a dashed line. And it should be dashed because I have just a less than sign. I don't have an equal to as part of that. So it's just less than, just dashed. Okay, once I've determined my line, I need to select a test point. The test point is going to help me know what side of the line to shade. I tend to like my test point to be the ordered pair 0, 0. It provides easy arithmetic, but I have to make sure that it's an ordered pair that my line does not pass through. And we can see from our picture that our line does not pass through the ordered pair 0, 0. So I can use that test point. If my line had passed through the ordered pair 0, 0, I would pick any other ordered pair that I wanted as long as the line did not pass through it. Okay, now that I've selected my ordered pair as 0, 0 for my test point, I substitute that into my original inequality. I follow the order of operations and get 0 is less than 15. This is a true statement. This tells me that the side of the line where 0, 0 is at is the side that I need to shade. That's why this side is shaded in yellow, because it is the side where all the statements are true. All those ordered pairs will make the inequality true. So down below in part 3, I say the shaded side of the line shows all of the ordered pairs that satisfy the inequality 3x minus 5y is less than 15. Now the ordered pair 1, 1 is also on the shaded side, and if I plug this into the inequality, it's true. I could pick any of the ordered pairs in that yellow side and always come up with a true inequality. As a reminder, for those students that are in linear algebra and probability, you're going to shade the opposite of the true side. You're going to be shading the false side.